there, algebra friends. Today we are going to be talking about 9.3.2, what if the inequality is not linear? So we are still going to be focusing on this new two-variable world where we have x's and y's in our inequality, but we might see one that doesn't, the boundary is not necessarily a line or a point. The boundary could be anything. So that's what we're going to get to today. But first, since I asked you if you have any pets yesterday, here's more of a dream pet scenario, is if you could have any pet, what would you want? So for me, I think corgis are the cutest thing in the entire world. I think a corgi is just the cutest. So if I could have any pet, I would want a pet corgi. So tell me, what would be your dream pet? Even if you love your pet dearly, what kind of pet would you like? Maybe what would you name it? Do you have a name for it? I don't have a name for my corgi yet, but something mathy might be kind of fun. All right, so we are going to get started here today, folks, with a little 977 here has us reviewing what we learned about last lesson in 9.3.1 by graphing the inequalities below, okay? So letter A here is y is greater than or equal to negative 5/3 x minus 3. Okay, so first question is the line going to be dashed or filled in? And I can say that it's going to be filled in because of that or equal to. And if you need to like kind of still make a note of like or equal to means I include it, so it's filled in. And if there's no or equal to, it's not include and it's dashed, okay? So this is a filled in line and this is a dashed line, if that little note helps, okay? So this boundary line is going to be filled in because it is greater than or equal to. My slope is negative 5/3, so that's going to be a downward slope there. My y-intercept is 0, negative 3. Okay, so let's first get graphing that. So I'm going to go down to negative 3 for my y-intercept. My slope is negative 5/3, so I'm going to go down 5 over to the right 3. Okay. 1, 2, 3, 4, 5 over 1, 2, 3. Okay, so those are my 2 points. Now I'm going to use this line tool to build my line nicely. There we go. That looks pretty good. And make sure you have arrows and make sure that the line, oops, that looks a little wobbly down there, but that's okay. Make sure your line extends for the whole coordinate plane because that makes shading, shading above or below more clear, okay? So make sure it extends the whole way there. And my line is filled in, so I don't need to dash it or do anything crazy there. And now, am I shading above or below? Because this sign up here is a greater than, I am going to shade above the line. So shade going up. So there we go. And this is when get creative, shade away. We could shade the whole thing, but I'm kind of lazy, I guess. Okay, so I'm going to shade above. So let's make sure I answer that above because it is greater than. And that's all I've got to do there, folks. And let's make sure we remember how to check our work here. This is going to be super key, greater than or equal to, and then I'm going to have negative 5/3, make sure the x is up there, and then it's going to be a minus 3. So I kind of like to see it graphed on Desmos. It looks pretty. We can see that it's filled in, check your intercepts here and shade above, right? So it looks like ours over here, right? Awesome. So we know we're good to go. So looks good. Let's try this next one over here. I'll switch colors here. So dashed or filled in is our first question here. So this symbol is a less than symbol. So that is going to be dashed. We are not including my boundary line here. My slope is a positive 3. And to make it a fraction, remember, I can divide anything by 1, right? That's still going to be equal 3. But writing it as 3 over 1, tricks my brain into thinking, okay, I'm going to go up 3 over 1. So I like to write slopes as a fraction there. My y-intercept is a positive 5. So let's go ahead and graph our boundary line, and it does have to be dashed. So I'm going to go up 1, 2, 3, over to the right 1. So those are my 2 points. I like to use my shape tool. When it's dashed, I like to use a light color for my line, and then I'm going to end up going over it in pink to show that it's dashed. So however you exactly want to do it, but make sure your teacher can see that it's dashed, okay? So that we know that the boundary line is not included, okay? So our last step here is if we shade above or below, and because that my symbol is a less than up here, we are going to shade below. So it's going to look something like this. Okay. And let's check our work using Desmos here. Y is less than 3x plus 5. Awesome. So we can see the dashed line here. We can see our y and our x intercepts to make sure, our graph looks comparable. And sure enough, we're shading below and we have a dashed line. So that looks really great. Okay. Awesome. I'm just going to shade this in a little bit more with the highlighter tool. I like that. Okay. So that's a review on our 2 variable inequalities where we can see the shape of the boundary is going to be a line, right? We can see that because this is in mx plus b form. However, that doesn't always have to be the case. So if you look over here, x squared minus 4, what shape is that going to give me for my boundary? I wish that you could all scream out for me, parabola! It's going to be a U shape, right? Because of that squared, that x squared minus 4. Okay, so this boundary is going to be a parabola. So your boundary can be any shape that your graph is, right? So that's kind of cool here. So we're going to graph this parabola. So you might think x squared minus 4, we could factor that to find the intercepts. Absolutely, like kind of tie in what we did last time here. So I'm going to type mine into Desmos. So I'm just typing in x squared minus 4. And sure enough, there's my parabola. I don't know how to get rid of this thing, admittedly. I want it to go away. So I'm just going to move it around. Okay. I want to pull up a table here. So I'm just, oh my goodness. I just pulled up my table for my parabola here. And so let's just copy that table down now. So if you look over here, so I'm just going to copy down the y's here. So 0, -3, -4, -3, 0. Okay, so those are the points on my parabola. So you can see the x-intercepts are -2 and +2. So if I wanted to write this as a factored, in factored form, it would be x plus 2, x minus 2. Just trying to tie it all in, okay? Right? If my x-intercept is -2, the factor is the opposite, x plus 2. That step's not quite necessary, but just kind of tying it all in. All right. Dashed or filled in? Should my boundary parabola be dashed or filled in? We look at the inequality sign, which is greater than. So that's going to be dashed where it's not included, okay? So let's graph our parabola here. So I'm just going to plot the points. So -2, 0, -1, -3, 0, -4, 1, -3, and then 2, 0. And this should be a dashed parabola. So I'm going to fill this in. Again, make sure your graph takes up the whole coordinate space, because otherwise shading gets confusing if your regions aren't broken off, right? Your boundaries should be a boundary with arrows extending, okay? And so there's my boundary parabola. Looks pretty good. Do I shade above my parabola or below? Okay, so we look back at this symbol here. It is a greater than, so I would shade above. So I'm just going to shade above my parabola. So that means lines going up, okay? And the cool thing is, folks, I can type this guy right into decimals as well. So I'm going to type in y is, where's y? Y is greater than x squared minus 4. So I can type that exact thing into decimals, and sure enough, I get a parabola. The boundary is dashed. We are not including the parabola itself. And sure enough, it is shaded above inside the parabola. It kind of looks like a glass of purple grape juice. So that's kind of how this works, right? And I love decimals because you can extend and see that solution is going up and up. That solution set goes all the way up into infinity and beyond. So cool. That is what you would do if it's not linear, right? So your boundary doesn't have to be linear. It can be anything. So feel free to play around with that. What if it was cubic? What if it was this? What if it was that? So that's how that works, folks. And so try the review preview. We've got a couple more linear. I didn't give you any parabolas in the homework, so don't be too scared here. And then we've got a bowling problem, which is kind of a nice problem, I think, because it's really realistic, where Charlie brings $20 to the bowling alley. How many games can he play? So I find that kind of relatable, right? You bring money out and you're like, okay, how many French fries can I get with the money that I have? And then we've got a little quadratic review problem for you, all right? So hope you're doing well, folks. Let me know if you have any questions, all right? See you later.